Okay, today I am going to explain how to solve non-homogeneous linear differential equation for basic trigonometric functions, sin ax or cos ax. You know how to find pi, phi of x by f of d. Here I will take sin ax divided by polynomial operator. While finding the pi in case of the trigonometric functions, you have to replace only d square term by negative quantity minus into a square. Okay, minus into a square, very important. Then pi becomes sin ax divided by f of minus a square, provided denominator term f of minus a square is not equal to 0. By chance, f of minus a square is 0, then multiply numerator with x, differentiate f of d with respect to d, and again replace only d square term with minus a square, provided f dash of minus a square is not equal to 0. Similarly, suppose f dash of minus a square is equal to 0, then pi is again multiply numerator with x, then we get x square sin ax divided by f double dash of minus a square, provided f double dash of minus a square is not equal to 0. Okay, actually this is the procedure. We have to continue this procedure till we get non-zero quantity in the denominator. Okay, suppose, see, if it is third order, fourth order, fifth order differential equation, in that case we get d cube, d power 4, d power 5, etc. If we have d cube, write it as d square into d, then replace d square by minus into a square. If you have d power 4, write it as d square into d square, then replace this d square by minus a square, again this one by minus a square. Minus a square into minus a square, it becomes plus a power 4, like that. Okay. Suppose if you have d power 5, write it as d square into d, then replace d square by minus a square, this d square by minus a square into d. Okay. After substituting d square by minus into a square or d cube with, if you write it as d square into d power 4, after simplification, finally either we end up with d plus a or d minus a in the denominator. If we have d plus a in the denominator, multiply and divided by its conjugate. Okay, d plus a conjugate is d minus a. If it remains with the d minus a, multiply and divide by its conjugate. What is the conjugate of d minus a? D plus a. Okay, multiply and divided by its conjugate. If we have d plus a or d minus a, and we remains only with the d in the denominator, that is 1 by d. In that case, integrate directly. Integrate only the original function. Okay. Now we'll come to the problems. Solve y double dash plus 4y is equal to sin 2x. Okay. This can be done as like this. D square plus 4 into y is equal to sin 2x. Right auxiliary equation, find the roots. Roots are plus or minus 2i. M is equal to 0 plus or minus 2i. Then CF is e power 0x into C1 cos 2x plus C2 sin 2x. Okay, now come to the PI. Sin 2x divided by d square plus 4. RHS function divided by f of d square plus 4. Now, according to the rule, you have to replace only d square by minus into a square. What is a here? A is 2. A square is 4. Okay, we have to replace this d square by minus into 4. Here, if we replace by minus 4, we get minus 4 plus 4 is 0. We get denominator as 0. Okay, what is the condition? F of minus a square is not equal to 0. Since we get 0 in the denominator, multiply numerator with x and differentiate this polynomial. If we differentiate this, we get 2d plus 0. Derivative of d square is 2d plus 4, that is 2d. Okay, x into sin 2x divided by 2d. See, in the denominator, we remains with only d term. If we remains with the d in the denominator, we have to integrate, but while integrating, you have to consider only the original function, sin 2x, not x. Okay, we get x because of the denominator is 0. Okay, then x by 2, integrate sine 2x with respect to x. What is integration of sine 2x? Minus cos 2x divided by 2. Okay, then pi is minus into x cos 2x divided by 2 into 2 is 4. Okay, now write the general solution. CF plus pi. CF is c1 cos 2x plus c2 sin 2x, and pi is minus x cos 2x divided by x. Okay, now come to the next problem. Next problem is y double dash plus y dash plus y is equal to sin 2x. Okay, see, write polynomial operator, auxiliary equation, find the roots, write the CF depending on the roots. Here roots are imaginary. Okay, now come to the pi. Sin 2x divided by d square plus d plus 1. According to rule, you have to replace only d square term by minus into a square. What is a here? 2 minus into 4. 2 square minus 4. Okay, minus 4. Write d as it is and 1. If you simplify, we get d minus 3. We get d minus a form or d plus a form. Okay, d minus a or d in general. D plus a or d minus a. Okay, here we have d minus 3 multiplied and divided by its conjugate. What is the conjugate of d minus 3? D plus 3 multiplied and divided by d plus 3. Okay, simplify the denominator. Denominator is always a minus b into a plus b form. If you multiply with conjugate, a minus b into a plus b is a square minus b square, that is d square minus 9. In the numerator we have d plus 3. D plus 3 into sin 2x divided by d square minus 9. Okay, and again use same procedure. Replace only d square term by minus into 2 square. Here a is 2 minus 2 square. See, minus 2 square is minus 4 minus 9 is minus 13. But in the numerator we have d plus 3. Operate d on sin 2x and 3 on sin 2x. D on sin 2x plus 3 sin 2x divided by minus 13. Okay, d means differentiate sin 2x. What is derivative of sin 2x? Cos 2x into 2. Okay, derivative of sin is cos and derivative of 2x is 2. Cos 2x into 2 plus 3 sin 2x divided by minus 13. This is your pi. Now write the general solution with CF and pi. This is your CF and pi. Okay, now come to the next problem. See, y with triple dash plus y double dash minus y dash minus y is equal to cos 2x. Here we have cos, but same procedure. See, this is your polynomial operator. Write the auxiliary equation. Roots are real and distinct here. One root is real and distinct, and another two roots are real and equal. Write the CF. Now come to the pi. See, we have d cube. If you have d cube, write it as d square into d. Okay, see, d square into d. Next to d square minus d minus 1. Now replace d square by minus a square. What is a here? Again, a is 2 only. Minus 4. That means minus 4 into d minus 4d minus 4 minus d minus 1. If we simplify, we get minus 5d minus 5 in the denominator. If we take minus 5 common, we get minus 1 by 5 cos 2x divided by d plus 1. Okay, here we have d plus a form. What is the conjugate of d plus 1? It is d minus 1 multiplied and divided by d minus 1. Directly you can write denominator as d square, a square minus b square form. D plus a into d minus a is d square minus 1 square only. That is d square minus 1. Okay. Now again use same procedure. Replace d square by minus 2 square. That is minus 4. Minus 1 by 5. D minus 1 cos 2x divided by minus 4 minus 1 is minus 5. Okay. Now simplify the numerator. D on cos 2x minus 1 into cos 2x. Derivative of cos 2x is minus 2 sin 2x. Derivative of cos minus sin into derivative of 2 is 2. Minus 2 sin is derivative of cos is sin. Minus 2 sin 2x minus cos 2x divided by 5 into 5, 25. And it is positive. My negative into negative, positive. Okay. Then this is your pi. Write the general solution with CF and pi. Okay. Add both CF and pi. Next one. See. Here we have y double dash plus 9y is equal to cos 2x into cos x. Cos A, cos B formula. Okay. if we have product of the two trigonometric function, and that may be sine, cos, cos, etc. Use the formula to convert into the one function. Okay, see, yeah, d square plus 9 into y is equal to cos 2x into cos. M square plus 9 is equal to 0 is the auxiliary equation. Roots are plus or minus 3i. This is your CF. Now come to the PI. Since your product, use cos A, cos B formula. Cos A into cos B. Okay. Now, that is 1 by 2 cos 3x. 2 plus 1, 3. Cos A plus B plus cos A minus B is 2 minus 1 is cos A. 1x. Okay. Divided by 2. Take 1 by 2 outside from the bracket. Then we get to 2 terms. Separate it. Now use same procedure. Replace d square by, what is a here? A is 3. That means replace d square by minus 3 square. That is minus sign. If you replace d square by minus 9, we get minus 9 plus 9 is 0. Here we get to 0. So multiply numerator with x, differentiate denominator. Next term. Cos 2x divided by, here what is a? A is 1. Replace d square by minus 1 square. That is minus 1. Minus 1 plus 9. We get cos x by 8. Directly, this is your PA for the second term. But for the first term, you have to multiply numerator with x and differentiate denominator. Because after replacing d square by minus 3 square, we get 0. Okay? So x into cos 3x divided by 2d. Now, since we have only d term, integrate it. Okay? X by 2, take outside from the integral, you have to integrate only cos 3x. Integration of cos 3x dx plus cos x by 8. What is integration of cos 3x? Sin 3x divided by 3. Okay? Then multiply it. X into sin 3x divided by 2 into 3, 6 into 2, 12. And 8 into 2 is 16. This is your PI. Then write the general solution, CF plus PI. Y is CF and PI. Okay? Next one now. Y double dash plus 3y dash plus 2y is equal to cos square x. Okay? Now, this is your differential equation with polynomial operator. Y double dash is d square, 3y dash is d plus 2 into y. Auxiliary equation, find the roots, write the auxiliary complementary function. Now come to the RHS. We have cos square. Convert into sin or cos ax form with power 1 always. Okay? Cos square x can be done as, see, cos square a is 1 plus cos 2a divided by 2. If it is sin square, 1 minus cos 2a divided by 2. Since we have cos square, it is 1 plus cos 2x divided by 2. Okay? Take 2 outside, 1 by 2 outside. Then we get first term is 1 by d square plus 3d plus 2. Second term is cos 2x divided by d square plus 3d plus 2. This one, first term is first type. See, if you have one constant term, write it in terms of exponential function. One can be written as e power 0x. 1 into e power 0x. Now replace d by 0, type 1. Okay, in the previous class I explained how to find PI in case of exponential function. Replace d by 0. This term becomes 0, this term becomes 0. Then we get 1 by 2 only. PI of the first term is over. Now come to the second term. Second term is case 2, trigonometric function. We have to replace d square term by minus 2 square, minus into 2 square. Okay, 1 by 2 into first term PI is 1 by using type 1, okay, for exponential function. Now come to second term. Cos 2x divided by, if you replace, see, d square by minus 2 square, we get minus 4 plus 3d plus 2. Okay, minus 4 plus 3d plus 2. Okay, then 1 by 2 into 1 by 2 plus cos 2x divided by 3d. If you simplify, you get 3d minus 2. Okay, now 3d minus 2, it is d plus a or d minus a form. Okay, multiply and divide by what? Conjugate of the denominator. Okay, what is conjugate of 3d minus 2? 3d plus 2. Okay, if you multiply 3d minus 2 with 3d plus 2, we get a plus b into a minus b, a square minus b square, 9d square minus 2 square, 9d square minus 4. Again use same procedure, replace d square by minus a square. What is a? 2 minus into 2 square minus 4. Okay, see 1 by 2, 1 by 2, 3d plus 2 cos 2x, 9 into minus 4 minus 4. Now 1 by 2 into 1 by 2 plus. Now if you simplify this, 40. Okay, 9 4, that is 9 4 36 minus 36 minus 4 is minus 40. Now operate 3d on cos 2x and 2 on cos 2x. 3d on cos 2x, 3 into derivative of cos 2x is minus 2 sin 2x plus 2 cos 2x. Okay, simplify this. If you multiply 1 by 2 with all the terms, you get 1 by 4, 3 by 40, see 3 by 40 into this 2, that is 80. Okay, and no, that is 40 only, because this 2 gets cancels, that is 40 only. Okay, and again 2 and this 2 gets cancels, we get 40. It is correct. 1 by 4 plus 3 by 40 sin 2x minus cos 2x divided by 40 is your pi. General solution is CF plus pi. Okay, write the general solution, that is CF and pi. That gives the solution of the given differential equation. Okay, next in the next class I will explain how to find pi in case of polynomial function. Okay.